Hi everyone, let's solve a LeetCode problem using Swift. The problem is called rotting oranges. You're given an m by n grid where each cell can have one of three values: 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent, meaning either up, down, left, or right, to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. When it is impossible, when, for example, an orange is in the corner and there are no adjacent rotten oranges to that fresh orange. Okay, let's take a look at the example. So here we have a minute 0, and we have just one rotten orange in the top left corner. Actually, we can have multiple rotten oranges in the beginning, but in this example, we have just one. So in the first minute, 2 adjacent oranges to that one, this one and this one, are becoming rotten as well. So you can you can see that here in the first minute we have 2 more rotten oranges. In the next minute, 2 more, which are also adjacent to the ones that were rotten before, become rotten. And then minute 3, another one adjacent orange becomes rotten, and in the minute 4, the last orange is rotten. So the output for this problem is actually, you can see here, 4, meaning we need 4 minutes for all oranges to become rotten. Alright, how to solve this problem? So we have a grid 4 by 4 with 2 rotten oranges in the top. So the most important thing that we need to understand is that we need to think of this grid as of a graph, where adjacent cells are like nodes with connections in the graph. And for graphs, we have two most important algorithms: DFS and BFS, depth first search and breadth first search. So for this particular problem, we need a BFS because we want to go level by level. And to implement a BFS, we need a queue, and we need to initialize that queue with our 2 rotten oranges. After that, we need to go step by step, and the adjacent oranges would become rotten, meaning these 2. After that, we need to update our queue. We need to pop the old oranges because we don't need them anymore, and we need to add these 2 oranges. And then go step by step, rotting oranges like level by level. When we need to stop, we actually need to stop when we have nothing in the queue anymore. So when the queue is empty, it means that our BFS is finished. All right, but how to handle a situation when we have, let's say, one orange sitting in the corner, not adjacent to any of our rotten oranges? In this scenario, we actually need to keep track of how many fresh oranges do we have from the start. So from the start, we had 1, 2, 3, 4, 5, 6 oranges. And then as we go with our BFS algorithm, we just need to do -1, -1, -1. And then in the end, if we have fresh oranges more than 0, meaning there are some oranges remaining, then it means that it's impossible to have everything rotten, and we need just to return -1. If we don't have this orange, then we just need to return how many steps or how many iterations we needed to have all oranges rotten. So we had 1, 2, 3, 4. So in this positive scenario, we just need to return 4. Okay, let's code the solution. So first of all, we need to make our grid a variable. Then we need to create a counter for our fresh oranges and initialize it with 0. Then we need to create our queue for BFS, which would be an array of tuples of integer. Okay, then we need to do a first scan through our grid. So like this, for I in from 0 to grid count, and then for j in 0 to grid first element count. So we're going through each element in the grid. And here we want to do two things. First of all, if grid from I j is 1, meaning it is a fresh orange, then we need to increase the number of oranges by 1 plus 1. And another thing that we want to do is if grid of ij, meaning the current element, is 2, so it is a rotten orange, then we want to initialize our queue with that orange with its coordinates ij. Okay, this is the first scan through the grid. Now, first of all, if our count of fresh oranges is 0 right away, then we can just return 0, because we need 0 minutes to complete the BFS. Okay, for our scan, we need a thing called directions, which is an array of multiple directions. Let me just show you a little later why we need this. So it would be 0, 1, 0, minus 1, and 1, 0, and it should be minus 1, 0. Okay, we have multiple directions where we can go. And we have minutes. We can start with, actually we can start with minus 1 and then add minutes on top of that. Okay, let's do our BFS now. So we would need a while loop that is checking if the queue is empty or not. So if it is not empty, then we're continuing. And inside of that, we have multiple ways how to pop from the queue. And actually the easiest could be like just first of all, creating a copy of the queue. So we can just create a copy of the queue and then make it an empty one. Then we also need to increase the number of minutes by 1 in each iteration. And then we need to go for every rotten orange in the queue, actually in the queue copy, in the previous queue. And then we need to check all directions, basically. So because we have multiple directions, up, down, left, and right, for that we can just simplify code by using this structure. So for direction, in direction, so we iterate through all of them. Then we need to calculate our new row, which would be actually our current orange position plus direction, and then we need to calculate a new column position, which would be again our current orange but x position plus direction from 1. And then we need to check if this new position is actually in bounds. So for that we just need to check if it is more or equals to 0, if it is less than grid count. So for column it should be again more than 0, and column should be less than grid count. And the most important thing is that our position, meaning grid from row column, should be actually 1, meaning a fresh orange. So if you have a fresh orange, actually let me fix here, it should be let. Yeah, so if we found this fresh orange, then we actually need to make it rotten. For that we would access our grid, again for coordinates row column, and make it 2, because 2 is a rotten orange. Then we need to our new queue, we need to append this newly rotten orange. So it would be append row column, and then we need to decrease the number of total fresh oranges. It should be -1. All right, looks good. And after all that, we just need to return. So first of all, we need to check if our fresh oranges is more than 0, then we just need to return -1, meaning we have some fresh oranges remaining. So we need to return -1. If not, then we just need to return our minutes, meaning how many steps it took to have all oranges rotten. Sorry, here a small mistake. It should be grid from 0. All right, it should be working now. Let's run it. Awesome, it works. Thanks for watching and have a great day.